Section 3.2, Day 2, using algebraic methods to solve linear systems. Here's the essential question. How do I solve systems of equations using elimination? Please stop the video and write that down. So like it says here, we can also solve systems of equations with the elimination method. With that method, we are getting rid of one of the variables by adding or subtracting equations. I always say adding. Elimination means add. So I'm going to write that down. Elimination means add. Sometimes we can just add two equations together and one of them eliminates. But other times we have to multiply one or both of the equations by a multiplier in order to cancel a variable when we add equations together. So far now, after today, we will have three methods for solving systems of equations. 1, graphing. 2, substitution. And 3 is elimination. So let's do example 1. We're using elimination to solve the system of equations. So I start by going like this, and I'm going to add. So when I look at the x's and I look at the y's, I can see that I'm not going to have to multiply either equation by anything, because if I add 7y plus a negative 7y, the y's are going to cancel. So if I take 4x plus a negative 12x, I get a negative 8x. They cancel, and negative 25 plus 19 is a negative 6. And I continue to solve. X, they cancel. So negative 6 over negative 8, well, that's going to be a positive 6 over 8. And it's a fraction that I'm going to just reduce. So I know that what number will go both into 6 and 8? 2. 2 can divide into 6 3 times. 2 can divide into 8 4 times. There is my x value. So just like we did in the substitution method, to find the y value, we plug the x value into one of the equations. And I'm looking, and it really doesn't matter which one, but I'm going to pick the first one. So 4, and in place of the x, I'm going to write 3 over 4 plus 7y equals negative 25. So what I just did is I took this answer and I plugged it into there, which is right there. So 4 is like 4 over 1. So 4 over 1 times 3 over 4, that's just going to be 3 plus 7y equals negative 25. Subtract the 3 on both sides. I think what I might have to do is draw a little arrow, and we're going to finish it up here. Now we have 7y is equal to negative 28, negative 25 plus negative 3. Divide both sides by 7, and y is equal to negative 4. So my solution then is 3/4 negative 4. Because we found one solution, remember, I'm just kind of adding something on here. We would call that one solution. And when we get one solution, that refers to intersecting lines. Let's go down to example 2. On example 2, looking at adding the x's, adding the y's, nothing is going to eliminate. So then I can choose which one will be easier to eliminate, the x's or the y's. Well, in this case, because the 3 has a negative and the 5 has a positive, they'll probably be the easiest to eliminate. So I'm thinking, okay, let's highlight something here. We have a 3 and a 5. So what I really think then is, what two numbers will 3 and 5 both divide into? Well, 15. So, or another way you could think of this is, if I have the negative 3y here, I'm going to take the top equation times 5 and the bottom equation times the 3. So now when I do that, I have to take the 5 times every single term and the 3 times the same thing every single term. Don't forget the number on the other side of the equal sign. A multiplier, I can do this in algebra. If I multiply the left side of an equation and the right side of the equation by the same number, that is okay in algebra. So I get 25x minus 15y. So 5 times 42 is 210. 3 times 8x is 24x. 3 times 5y is 15y. And 3 times 28 is 84. Remember, elimination means add. So 25x plus 24x is 49x. That they eliminate. That's what I planned. And 210 plus 84 is 294. Divide both sides by 49. X is equal to 6. So there's my x value. Now I'm going to take that x value and I'm going to plug it into either one of the original equations. So I'm going to pick this time the bottom one. Okay. Let's just scroll down. How about? So the equation I'm going to use is the 8x plus 5y equals 28. And I'm going to take my answer and plug it in right there. 8 times 6 plus 5 times y equals 28. 8 times 6 is 48. And let's turn the page here. Minus 48 on both sides. So I get 5y is equal to 28 minus 48. Well, that's just going to be a negative 20. Divide both sides by 5. Y is equal to negative 4. Perfect. So my solution then is, our x value was 6, our y value was negative 4. So again, if I wanted to classify this, I would say one solution, which is intersecting lines. I didn't ask for that. When I say solve the system of equations, all I need is this answer, 6, negative 4, because the solution is an ordered pair. So back in lesson 3.1, we learned that systems may have infinitely many or may have no solutions. So we've talked about this in class a lot. Remember, we can have one solution, no solution, or infinitely many solutions. When looking at a graph, it's pretty evident that one solution is where they intersect, no solution, that goes with parallel lines, and infinitely many solutions mean it's the same line, coinciding lines. So we're going to classify the system and determine the number of solutions. So we're not solving the system, we're going to determine the number of solutions, and we're going to use elimination. The x's won't cancel, the y's won't cancel, and I'm going to say, oh, you know what? Let's eliminate the y's, because if I multiply this bottom equation by negative y, then the y's will cancel very nicely. So I'm going to rewrite the top, 56x plus 8y equals negative 32, because I don't have to change that equation. And if I multiply that, I get negative 56x minus 8y equals 32. Oh, well, those cancel, those cancel, those cancel. So if everything cancels, that's 0 equals 0. Oh, we haven't run across this yet. Well, what this means, you ask yourself, is that a true statement? Yes, this is a true statement. When all of your variables cancel, which they did, it's either going to be a true statement or a false statement. A true statement means that you're going to have infinitely many solutions, which goes with coinciding lines. That means that if I would put these both in slope-intercept form, they would be the exact same line. So when it says classify and determine number of solutions, we would say infinitely many solutions, and they are coinciding lines. Now, the one thing I want to mention, example 4 and 5, we are going to do in class. But if we would have a scenario, I want to write something down quick, and instead of a true statement, we would have a statement like 4 equals 5. That is a false statement. If you get a false statement, that's when you would say no solution, and that goes with, obviously, we already know, parallel lines. All right, this is a quick review, which we've kind of talked about already, but we have 3 methods: graph, substitution, elimination. Possible solutions are one solution, no solution, which are parallel lines, infinitely many solutions, which is the same line, which we call coinciding lines, and one solution is intersecting lines. Here are the video questions. Please stop the video here and do these questions in your notes.